We want to welcome you to the Dallas Independent School District STEM Environmental Education Center virtual field trip. I want to say a very special welcome to Callier and Maple Lawn from Dallas ISD. Thank you for joining us today. We hope you enjoy the program and learn something. Teachers, if you're watching and you're not signed up, please do so. Go to www.county.cc/3-5 registration. Sign up for us, please. Program today will be weather. What an appropriate program. During this virtual field trip, students will observe and compare day-to-day weather changes in different locations at the same time. Mr. Ramirez will tell you about the temperature. Mr. Monroe will discuss clouds, precipitation by Mr. Dominguez, wind by Ms. Schramm, and Texas weather and climate by our guest, Mr. Copeland. Students, you cannot ask us a verbal question today, but you can go to www.county.cc/question-answer and fill out a form and send it in. We'll be glad to answer it. Now I'm going to stop sharing my screen. And Ms. Ramirez is going to tell you all about the temperature.
Temperature that day. In this segment, we are going to learn all about temperature. Temperature is simply how hot or cold it is outside, and we know that we can measure temperature using a science tool called a thermometer. Notice on our thermometer, it has degrees Fahrenheit and degrees Celsius. There is a liquid inside the thermometer. It's normally red, but it can be any color. When that liquid gets hot, it will start to rise. And when that liquid cools down, it will start to drop toward the bottom. So now I'm going to share my screen with you guys, and we're going to take a look at a quick little video of the Environmental Center and how temperature impacts our animals. This temperature reading was taken on Friday, January 7th. Notice that it was about 26 degrees Fahrenheit. That is super cold. It is actually below freezing that day. And that blue line is the freezing mark. It was so cold that the water in our duck pond actually froze. So we know that water freezes at 32 degrees Fahrenheit or 0 degrees Celsius. Once the temperature rises above 32 degrees Fahrenheit, the ice will eventually melt. There's a couple of our ducks. They unfortunately could not enjoy their pond because it was frozen. So here's some more of our farm animals. Think about, how does the temperature affect the farm animals? What do you guys think they're trying to drink right there? So we know that unfortunately their water bowl froze and it was frozen solid. We had to go over there and break that ice with a stick. And the top part of their water bowl was a frozen chunk of ice. But once we really got in there with the stick, we found that there was actually liquid water underneath. And you can see there's some of our pigs enjoying their water. And there's a huge chunk of ice. Now this video was taken during January and February, so of course we were in the season of winter, but think about how the temperatures will change as we go through spring and even the summertime. So we're going to start with our slide presentation. In this segment, we're going to be learning about temperature. Your focus questions for today are, hopefully by the end of this presentation, you'll be able to answer these two questions. The first is, what tool measures temperature? And the second question is, it's cold in Dallas, but it's even colder in Minneapolis. Why is that? And we have some cool little videos of snow and a blizzard in Minneapolis. Wouldn't that be fun to experience here in Dallas? So let's compare the temperature in Dallas, Texas to Minneapolis. Now, teachers, feel free to take a moment to pause the video to allow time for students to look at these two graphs. One is weather data for Dallas, Texas for this current week. The next is data from Minneapolis, Minnesota, also for this week. Now, I went outside on Monday and I took a picture of the thermometer here at our school, and the temperature read that it was about 66 degrees, and this was about 3 o'clock when I took this temperature reading. The first thing that I noticed is that on Monday, the temperature in Dallas, the high was 67. But if we look over here from Minneapolis, their high was only 31 degrees. Now, if we take a look at the predicted temperatures for the rest of the week, notice the big difference in temperatures. Dallas is much warmer with temperatures in the 50s, even the 60s on Tuesday. The temperatures do drop toward Thursday and Friday, but it's nothing compared to the temperatures that Minneapolis is experiencing. So notice Minneapolis, they have temperatures in as low as 5 degrees, even 9 degrees. So that is super cold. Those temperatures are below freezing. So why do you think that is? Why do you think Dallas has much warmer temperatures compared to Minneapolis? So temperature is affected by a few variables. The first and most important thing that affects temperature is what's called latitude. So essentially at higher latitudes, or the closer you get to the Earth's poles, that means that the sun's rays are less direct. So temperatures are going to be colder. So if we look at this diagram, here's our sun, here's those rays that are shining from the sun, and notice our planet Earth. So the rays of the sun are more directly hitting toward the equator. The locations closer to the equator experience much warmer temperatures. However, the further away you get from the equator, your temperatures are going to start to be cooler because the sun's rays are less direct. So the further an area is from the equator, the lower its temperatures are going to be. So here we can notice some climate zones. By the equator, we have more tropical temperatures. The further away you get from the equator, we have what are called temperate zones. And then toward the poles, we have our super cold regions, the polar zones. Now, if we look at this map of the United States, here's Dallas, Texas, where I am located. And then here is Minneapolis, Minnesota. So notice that Minneapolis is at a much higher latitude compared to Dallas, Texas. So its temperatures are going to be a lot colder than what we experience here in Texas. There are also other things that affect temperature, such as elevation, also things like landforms, such as if the location is by a large body of water or even mountains. So my challenge for you guys is to compare the temperature of your city to your dream vacation spot. And I've always wanted to go to New Zealand and Australia, so I'm super interested in what their temperatures are like during this time of the year. And that's all I have for you guys today on temperature. We're going to give it back to Dr. Borman to answer any questions.
Thank you, Ms. Ramirez. And the question came in, who actually invented the thermometer? The invention of the thermometer is generally credited to the Italian mathematician, physicist Galileo. There's different thoughts about that, but that's the general consensus. And now we're going to let Mr. Monroe tell us all about clouds.
Hello, everyone. We're going to be looking at clouds. In fact, if I was there at your school in your classroom right now, maybe your teacher will have you do this, or even if you were out here with us in an actual person-to-person field trip, I would have you go outside and look up at the sky and look at the clouds that we have taking up the space in the sky right now. And then I would ask you, because of the type of cloud that you're observing right now, what type of weather do you think we're going to have? And of course, hopefully by the end of this, my part of your virtual field trip today, you would come up with a good, correct answer. Now, talking about clouds, when I was very young and I saw clouds floating along in the sky, my first thought was, well, there must be a fire somewhere. But that wasn't true, was it? Because clouds are not actually smoke. In fact, I got a short presentation that I want to present to you, and hopefully it will help you understand what clouds are made up of. And then something else I want you to be able to do is to be able to identify the 4 major types of clouds, because those 4 major types of clouds, guess what? They can also predict or forecast the weather that we're going to have or what kind of weather we're currently having. So bear with me while I share my screen with you, and we'll get into the presentation. Clouds. First of all, let's figure out, or let's try to find out, how clouds actually form. You know, clouds form by a process that actually happens in something that you guys will be learning about if you already haven't, called the water cycle. You see, clouds form when water vapor in the air becomes liquid water or ice crystals. What we're looking at, you know, water can be found in the three natural states of matter in our atmosphere and on the surface of our planet. Now, when we're talking about the atmosphere, we're talking about the airspace around our planet. Now, meteorologists, those are very special scientists that study weather, they like to refer to the atmosphere as the air bubble that surrounds our planet, students. And in that air bubble, all the airspace above our planet, water can be found in the gas form, which we call water vapor, and then in the liquid form, usually in water droplets, and then in the solid form, in the form of ice crystals or hailstones, somewhere where the water droplets have frozen and they have become solid. Condensation is the process found in our water cycle that actually indicates that the water vapor, which is the gas form, has either cooled off because it's so high in the air, and it turns the water droplets back to form, it turns the water vapor back into water droplets that form the clouds. So right there, that tells you that clouds are not made of smoke primarily, but they are made up of water droplets. So clouds are actually water in our atmosphere. This is condensation and is part of, just like I said before, the water cycle. Now, there are several types of clouds. In fact, there's a lot of different types of clouds. And meteorologists, oh, there's so many types of clouds, they classify clouds according to their color, their shape and size, and where they form in the atmosphere. Now, the clouds that we're looking at in this image, if you were looking outside, most likely you would see clouds that look like this, the cloud formation that looks like this. And these clouds are actually stratus clouds. Stratus clouds can give you some information about what the weather is going to currently be like, okay? Now, in this image, you can see that it's not completely gray. You see some real light colors, and then you see some darker colors kind of mingled in. And that indicates that this is truly a stratus cloud. It covers up the sky like a sheet. Sheets of low gray clouds that bring light, like snow, rain, or drizzle. Well, we already know that there's not going to be any school tomorrow or Friday, simply because meteorologists have predicted that we're going to get some precipitation in the form of maybe some light snow, definitely some rain, and possibly some freezing rain. No doubt we'll probably have some drizzle also. Now, fog, that is another condition that involves a stratus cloud, a type of stratus cloud. And that's when a cloud is in contact with the ground. Again, fog is a type of stratus cloud. Gravity kind of pulls that cloud down to the ground, and it makes visibility very hard, our vision very hard to see. I can remember not too long ago, we did have some foggy mornings, and on my way to work, you had to really work at seeing what was ahead of you in the distance because visibility was very poor because of this type of stratus cloud coming to the ground. And then we have what we call the NIMBOSTRATUS cloud. Now, the NIMBOSTRATUS cloud is a little bit thicker than the stratus cloud. It's layered. It has thicker layers than a stratus cloud that completely blocks out the sun. This indicates that they may cause steady rain or snow. And I think that's probably going to happen later on today. It's going to start out as rain, and eventually as the air temperature cools, and you've learned about the temperature, how we gauge the temperature and everything. Once that air temperature gets below freezing, guess what's going to happen? We're going to have some type of frozen precipitation. Now, on the other hand, this is a different type of cloud. It is called a cumulus cloud. This is one of my favorite clouds, guys. These clouds can be a lot of fun. These white puffy clouds, they usually mean good or fair weather. Here are several images of different cumulus clouds. And just like I said before, they can be fun to watch. You know, people get kind of get interested in these clouds simply because they often see pictures in the sky made by cumulus clouds. I know a couple of times I've used my imagination, and some of those cumulus clouds, those little white puffy clouds, they kind of give me the impression when my imagination is really working that they resemble rabbits or some other animals that live in nature. And then we have cumulonimbus clouds. This is a cloud that I want you guys to remember, a cloud type, because one of the things I want you to be able to do is to recognize this cloud, because this cloud usually indicates that we're going to have stormy weather. These dark tyrant clouds are also called thunderheads. These clouds produce heavy rain, thunder, and lightning, and could produce some vortexes that we refer to as tornadoes. You know, the lightning, we have a lot of lightning strikes when it's happening in North Texas. Lightning can cause fires, it can cause lots of damage, and can injure people. Also, it could very well kill someone because lightning is a strong bolt of what we call static electricity, okay? It is said that a bolt of lightning can be hotter than the surface of the sun. Now, this is an image of a cumulonimbus cloud. You see the towering part, and it is said the part that is so towering and high in the sky, that's where the wind turbulence are found. That means the cumulonimbus cloud in this image has some very strong wind within the towering part of its formation. Here are several images of cumulonimbus clouds. Looks kind of threatening, doesn't it? You know, often they are referred to as nimbus. Cirrus clouds, it's the fourth type. Cirrus clouds, man, I love those. And cirrus clouds, guess what? They're feather-like clouds that are made up of ice crystals high in the atmosphere. Usually means a change in the weather is coming. Now, these clouds are so high in the atmosphere, actually, instead of being made out of water droplets, just like it says, ice crystals. You see, the further you go up into the atmosphere, the colder it gets, okay? Here are some images of some cirrus clouds. Sometimes they are actually referred to as mare's tails, okay? Horse's tails. What does the color of a cloud tell you? Well, it can tell you something. In fact, the color of a cloud lets you know how much water it contains. White clouds have very little water in it. And so that's why the cumulus cloud usually indicates good weather or fair weather, because they're little white puffy clouds, right? Dark clouds usually mean heavy rain. That means a lot of water droplets are making up that particular cloud. Gray clouds can mean snow or rain. And right now, if you were to step outside or look out of the window of your classroom, you would see the stratus clouds that are out there. They are a light gray. Where do clouds form? Well, students, guess what? They form at the edge of what we call weather fronts. These weather fronts are the boundaries between different air masses. Okay, I'm going to stop sharing my screen right here. And let's look at the water cycle. We know that there are several processes that happen in the water cycle. The changing of the liquid into a gas, we call that evaporation. Okay? Once that gas form enters the atmosphere, water vapor, and it begins to cool off, then it goes through what we call condensation. If there are dust particles or smoke particles floating around in the air, those water droplets are going to attach themselves to those particles and form a cloud. When that cloud gets so saturated, guess what? Water droplets will fall back to the earth. If the air temperature is above 32 degrees Fahrenheit, that's above freezing, we get rain. If it's below 32 degrees Fahrenheit, we get snow or some type of frozen precipitation. Well, hopefully I've helped you understand a little bit about cloud formation and the major types of clouds. I'm going to turn it back over to Dr. Gorman. So if any of you have any questions, I bet he can answer them for you.
Thank you, Mr. Monroe. And a student did ask a question, is how high do clouds get? Okay, clouds can reach as high as 45,000 feet above the earth. And now Mr. Dominguez is going to tell us about precipitation.
Hola amigos, estoy afuera de nuestro centro de ciencia y el tema de hoy es la precipitación, pero no miro ninguna seña de precipitación. ¿Qué es la precipitación? Pues la precipitación es el vapor de agua que se condensa en nuestra atmósfera y cual cae hacia la tierra en diferentes formas. Sabemos que el agua tiene diferentes formas, ¿verdad? Entonces, claro que la precipitación también tiene diferentes formas. Y eso es lo que voy a explorar hoy. So guys, today's topic is precipitation. And I'm outside our beautiful Environmental Education Center, and I don't see any signs of precipitation. So what is precipitation? Well, precipitation is the water vapor that has condensed in our atmosphere and that falls back down to Earth in different forms. We know that water has different forms, so of course precipitation has different forms too. Before we get started with the different forms of precipitation, I am going to show you a very special tool that measures how much rain we've gotten. And we haven't gotten much rain, so I expect it to be empty. So let's go take a look. It's right there. Do you guys see that? This is what we call a rain gauge. Esto es un pluviometro. So this measures how much rain we've gotten. And since we haven't gotten much rain, or any rain at all, it's empty. So hopefully we get some rain or precipitation pretty soon. But in the meantime, I'll show you guys some different examples. I really wish we had a very special type of precipitation that some other places get during the winter. But unfortunately, here in Texas, it's a little bit too hot for us to get this type of precipitation. What kind of precipitation do you guys think I'm talking about? We had a lot of it last year, but so far this year, none. All right, guys, let's go back inside and get started. La primera forma de precipitación que quiero mencionar hoy es la lluvia. Acuérdense que precipitación es el vapor de agua que se condensa en la atmósfera y luego cae hacia la tierra. All right, guys, so the first form of precipitation that I want to mention is rain. And remember that precipitation is just the water vapor that has condensed in the atmosphere and falls back to Earth. This is a beautiful example of precipitation. Una de mis favoritas formas de precipitación es la nieve. La nieve se forma cuando las temperaturas están a cero o bajo cero. Pero aquí en este estado, usualmente las temperaturas nunca están tan frías. So, one of my favorite types of precipitation is snow. But unfortunately, snow forms when temperatures are at zero or below zero. And here in Texas, our winters are usually above freezing. They weren't last year, so let's hope we get a little bit of snow this year too. Una de las formas más violentas de precipitación es el granizo. El granizo, como la nieve, se forma cuando las temperaturas están bajo cero. Pero miren a la forma de granizo. Son bolas grandes de hielo que pueden dañar no solamente a las casas, pero otra propiedad, como los carros. Y también pueden lastimar a los animales y a ustedes. One of the more violent forms of precipitation is hail. And hail, like snow, forms when temperatures are at zero or below zero. But unlike snow, hail comes in the form of big ice balls that can harm you and damage property, like your home and cars. El último ejemplo de precipitación que les voy a dar hoy es la aguanieve. La aguanieve es muy similar al granizo, pero la aguanieve es más pequeña y a veces viene mezclada con lluvia y nieve. The last example of precipitation that I'm going to give you guys today is sleet. And sleet is very similar to hail, but sleet is much smaller. And it sometimes comes mixed with snow and rain. So guys, I hope you learned a little bit about precipitation today. Before you guys go, I wanted to show you something pretty cool. So I wanted to show you little Teddy. He is my redfoot tortoise. He's right here. He's buried. And you may be wondering, is that smoke? No, it's actually a humidifier. So Teddy is a species that really likes it humid or pretty wet. So when it rains, when we have that type of precipitation, I usually let him go outside to explore because he really does enjoy it. But since it's so cold and it's so dry, what I like to do is I like to give him some fake precipitation, and he really loves it. So unfortunately, there's no precipitation and it's pretty cold outside right now. But as a redfoot keeper, I make sure that his environment is pretty humid, pretty wet. And as you can see, he's already started to perk up. So he's like, what is all this precipitation? I love it. All right, guys, have a wonderful rest of your day. I will see you guys next time.
Thank you, Mr. Dominguez. And a student says, would you please describe precipitation? Okay, we're going to use Wikipedia for our reference. In meteorology, precipitation is any product of the condensation of atmospheric water vapor that falls under gravitational pull from the clouds. And now we're going to have a program about the wind.
Good morning, everybody. It's Miss Shram, and today we are talking all about windy weather. So on the left, that's me and my chickens. They don't have much to do with the wind, but I just like them. And on the right is a picture of me flying a kite a few summers ago in Galveston. So we are going to be talking all about the wind. And by the end of my section of the field trip, you'll be able to observe, measure, record, and compare day-to-day weather changes, including wind conditions. So if you want to know if it's windy outside, all you have to do is look at the trees. That's our first tool that nature gave to us to tell if it's windy or calm. You don't even have to step outside. So of course, the palm tree on the left is still and the palm fronds are all spread out. And then the one on the right is all squished to one side and all the fronds are blown over. So you can tell that the left side is a calm day and the right side is a windy day. Simple enough. You can also look at the flag outside of your school or other buildings. So if the flag is resting and drooping down, you know it's a calm day. And if it's flapping in the wind, you know it's a windy day. You can also use a weather vane or a wind vane to tell you what direction the wind is blowing. So this tool tells you what direction it's blowing, and you'll see some student-made examples and also a real life one that you could get at the store. So if you've ever been to a ranch or a farm, you may have seen the one on the far right. Usually they have some sort of animal like a rooster, or in this case, a horse with an arrow. And then they have 4 letters, N-E-S-W, north, south, east, and west. Those are our cardinal directions. So the wind vane will tell you which direction the wind is blowing. And then those student examples are pretty simple. I've made those here in the science lab at the EEC. And they take just a few simple materials and they actually work. So the reason we need to know which way the wind is blowing is to know what weather is coming our way. And the reason we see those a lot of times at farms and ranches is because if you are working out in the fields and you see dark storm clouds over in the east and the wind is blowing from that direction, you know that you're going to have to get your chores done quick before that storm rolls in. So they are just a tool to help us predict the weather. You can also use an anemometer to measure the speed of the wind. So this tool tells us how fast the wind is blowing. And you'll see 2 real life examples and then 1 student-made example. So what they do is they have almost like a bowl-like dish that when the wind and the air moving presses against that dish, it turns it around in a circle. So there's a gear in the middle. So as those discs are spinning around, that gear is ticking and counting how much it spins, right? So then it's able to give you a measurement on the meter below that says how many miles per hour the wind is blowing. So speaking of wind speeds, we have the Beaufort scale that can help us understand different wind speeds. Because if I told you it was blowing 25 mile per hour winds outside, that's all well and good, but I mean, that doesn't really mean much to you unless you know what that's going to look like. So the Beaufort scale goes from 0 to 10, and it gives us kind of what to expect, what we can observe, and how to describe that type of wind. So we'll start at 0, and we're not going to go through all of them, but we're going to cover just a few. So a 0, smoke rises vertically. So if you had a fire and you're outside with your campfire, the smoke would go straight up into the air because the wind would be blowing at 0 to 1 mile per hour. So if you kept going, the wind, if it got stronger, it would start to blow over, right? And some other things start happening as that Beaufort number increases. So if we go halfway down at a number 6, you would be able to observe large branches swaying in the wind. You would be able to hear wires whistling, and that would be a strong breeze from 25 miles per hour to 31 miles per hour. So those are some stronger breezes. Then if we go all the way down to the final level, level 12, you would see extreme damage. That would be like hurricane level winds from 73 to 82 miles per hour. So those are really, really strong. So we're gonna see a kind of a pictorial representation. Now this is a little blurry, but you can still get the important ideas from it. So you can see at the beginning, over here is like the level 1 on the Beaufort scale. You can see that smoke rising from the house as we discussed, going straight up in the air. The flag, like we talked about, is going straight down. The palm tree is all spread out, looking normal. So that's a level 1. Then if we go halfway to level 6, you can see that palm tree, the fronds are all blown over, the smoke from the house is blown over, that flagpole is starting to bend and the flag is sticking straight out. So you know that wind is pretty strong if it's blowing it all the way out. Then as we move closer to level 12, well, you can see what happens, and you can see why I said extreme damages at level 12, because that little house and the tree and all that debris has been blown away at a level 12. So that is really, really strong extreme winds. So hurricane winds can also be measured in different categories. And similar to the Beaufort scale, we can see it starts low and then gets much, much stronger. And you can see, obviously, as the wind power increases, the category increases, and so does the level of damage. Other natural events that have extreme wind are, of course, tornadoes. So here we have another scale similar to the hurricane one. It goes from 0 to 5. This is the enhanced Fujita scale. So sometimes you might hear a tornado as referred to as like an F3, that's a Fujita 3, and that would have 136 to 165 miles per hour. So these help scientists study tornadoes and measure how strong the tornadoes are in a given area. So that is all I have for you today about the wind. I can't wait to see you next time, and I hope you enjoy the rest of your field trip. Thank you.
Thank you, Ms. Ram. And a student wanted to know, what are 2 beneficial benefits of the wind? And out here we have what we call a windmill, and it actually pumps the water out of the ground, and we use it to water our animals, and we also use it to help fill up our small pond. And another benefit is the windmills that actually produce electricity. West Texas, they have a lot of them out there. We don't have many around here. We don't have enough wind, I guess. And now Mr. Copeland is going to do a program called Texas Weather and Climate.
Hi, my name is Wesley, and I'm a meteorologist with the Texas Commission on Environmental Quality, but we call it the TCEQ for short. The TCEQ is a state agency that protects our environment and makes sure our air, water, and land is protected from pollutants. We also teach Texans about how they can help keep Texas's environment clean. I'm a meteorologist, but you might have heard the job called a weatherman. A meteorologist is a scientist who studies the weather and makes a forecast so we know what the weather will be in the future, which could be the weather tomorrow or the weather in a month. I'm a little different than the weatherman you see on TV. I track weather to study how it will affect our environment, as well as track how it affects air pollution. Sometimes pollutants can make our air dirty, which is especially important to know if you have asthma or other health problems. I make sure Texans know when the air is safe and clean to play outside. We use a colored chart to show how clean the air is. Green is the best and purple is the worst. Typically, we see orange ozone action days in the summertime when there's lots of sunshine and winds are light. They're also more common in big cities where there are more cars. To study the weather, I use weather measurements. Those are taken by air monitoring instruments and by air investigators. They work all across Texas, taking data with handheld monitors, air monitoring vehicles, and stationary air monitors. Their machines can sense lots of different things about the air that we can't see with just our eyes. They can tell us the temperature, pressure, humidity, and different types of invisible particles that are floating in our air. I use the information they gather to decide what that means for the weather and predict the amount of pollution that might be in the air. You can even monitor the weather yourself by using thermometers, rain gauges, anemometers, wind vanes, barometers, and hygrometers. Texas weather is very unique and special. Texas is very large, which means we have different types of weather across the state, even in a single day. It could be snowing in Amarillo while people in Corpus Christi are playing at the beach. In Texas, we have beaches and mountains, plains and hills, swamps and deserts, forests, and, well, you get the picture. Because of these different types of land, we see lots of different types of weather. Some of the types of weather we see in Texas are thunderstorms, hurricanes, tornadoes, snow, and fog. Texas has several different types of weather patterns that we see year after year in our state. Some common weather patterns we see are cold fronts, which are large areas of cold air that move across the state. Cold fronts cause some of the most interesting weather events that happen in Texas. When a cold front comes through, it's pushing the warm ocean air back out over the Gulf of Mexico and brings in the cold mountain air from the north. It happens all across the state as the cold front moves. This is why you might wear shorts one day, but the next day you might need a jacket. Another interesting weather event we see in Texas is hurricanes. They are very interesting to watch because we, as meteorologists, try to figure out where they are going to go. This is important so we can know whether or not it will cause problems for people who live close to the coast of Texas. It is important to know the difference between weather and climate. Weather is what is happening today and the next several days. Climate is the average weather over a longer period of time, like months and years. For example, even if the weather is rainy today, if it is the only time it has rained in the last 6 months, the overall climate during this time period would be dry. At the TCEQ, we track both weather and climate, since they are both very important. Thanks for taking the time to learn more about how the TCEQ helps you take care of Texas.
Thank you, Open. And now I am going to share my screen. During this virtual field trip, students observed and compared day-to-day weather changes in different locations at the same time. Ms. Ramirez covered the temperature, clouds by Mr. Monroe. Mr. Dominguez told you about precipitation. Ms. Ram told you about the wind, and Mr. Copeland discovered Texas weather and climate. Thank you, teachers. If you would, go to www.tiny.cc/3-5 feedback, fill out a short form and send it back to us. We would appreciate it. Thank you for joining us. Stay warm.